So the last part of the chapter deals with the topic nature of the roots. Now, in the previous part we learned that x is equals to minus b plus minus root under b square minus 4ac by 2a. So these are roots of the equation ax square plus bx plus c. So x equals to minus b plus minus root under of b square minus 4ac. Now we have a plus and a minus with this root. Now this b square minus 4ac can have three types of values. Either it can be greater than 0, or it can be equals to 0, or less than 0. So we'll consider these three cases. If b square minus 4ac is greater than 0, we get, say b square minus 4ac is 4. So there is a number minus b plus minus root 4, so plus or minus of 2. So if we add 2, we get a different number. If we subtract 2, we get a different number. So we get two distinct roots, two different roots. So if b square minus 4ac is greater than 0, we get two distinct real roots. One is minus b by 2a plus root under of b square minus 4ac by 2a, and the other is minus b by 2a minus root under of b square minus 4ac by 2a. So one with the plus sign and the other with the minus sign. Okay. Two distinct real roots. And so this is our first case. The second case is that b square minus 4ac equals to 0. Then what happens is x, this will be equals to plus minus 0. Then x equals to minus b by 2a plus minus of 0. So plus or minus 0, that is x is equals to minus b by 2a. If you add 0 also, we get minus b by 2a. If we subtract 0 also, we get minus b by 2a. So as you can see, the roots of the equation are both minus b by 2a. So this is real and equal. So therefore we say that there are two real and equal roots in this case. And the third part, if b square minus 4ac is less than 0, say root under of minus 1. Root under of any negative number is not defined on it. So if b square minus 4ac is less than 0, then there is no real number whose square is b square minus 4ac. Therefore, there are no real roots for this case. So because root under of b square minus 4ac will not be defined if the value of b square minus 4ac is less than 0. Okay. So now, as we have seen in these three cases, what happens if b square minus 4ac is greater than 0, then we get two real and distinct roots. If b square minus 4ac is equals to 0, we get two real and equal roots, and b square minus 4ac is less than 0, then there is no real number or there are no real roots. So hence we conclude from here that if there are roots, real roots or not is determined by b square minus 4ac. So with this, give this a name and we call it discriminant. So since b square minus 4ac determines whether there will be real roots or not, so b square minus 4ac is called the discriminant of this quadratic equation. Okay. So first example, find the discriminant of the quadratic equation (2x square minus 4x plus 3 equals to 0), and hence find the roots, find the nature of its roots. So solution: the given equation is of the form ax square plus bx plus c equals to 0, where the coefficient of x square, a equals to 2, b equals to minus 4 and c equals to 3. Therefore, the discriminant b square minus 4ac equals to minus 4 square minus 4 into a into c. That is equals to 16 minus 4 2s are 8, a3, 24. So this is a minus 8, which is less than 0. So we are getting b square minus 4ac less than 0. So the given equation has no real roots. Okay. Okay. Next question. Find the discriminant of the equation (3x square minus 2x plus 1 by 3 equals to 0), and hence find the nature of its roots. Find them if they are real. So solution. The given equation is of the form ax square plus bx plus c, where the coefficient of x square a equals to 3, coefficient of x b equals to -2, and the constant term c equals to 1 by 3. And therefore, the discriminant b square minus 4ac equals to -2 square minus 4ac is 1 by 3. So this is equals to 4 minus 4, that is 0. So equals to 0 means the roots are real and equal, hence the given quadratic equation has to equal real roots. Therefore, the roots are, we saw that if the roots are real, so and equal, what happens is the roots become minus b by 2a. So the roots are minus b is -2 by a, comma minus b by 2a, that is, it becomes 1 by 3, comma 1 by 3. So our roots are 1 by 3, comma 1 by 3. So both the roots are equal. The next type of question that you might get is find the value of k for each of the following for the quadratic equation kx into x minus 2 plus 6 equals to 0, so that it has two equal roots. So solution, first of all, we'll write the equation kx into x minus 2 plus 6 equals to 0. This implies kx square minus 2kx plus 6 equals to 0. So this is of the form ax square plus bx plus c equals to 0, where a is equals to k, and b is equals to minus 2k, and c equals to 6. As the roots are equal, which is given in the question that it has two equal roots, as the roots are equal, so discriminant b square minus 4ac will be equals to 0, because in case of equal roots the discriminant is equals to 0. So this implies b is minus 2k whole square minus 4, a is k, and the value of c is 6 equals to 0, which implies 4k square minus 24k equals to 0. So 4k comes common, which implies k minus 6 equals to 0, which implies 4 equals to 0 not possible. Either k equals to 0 or k minus 6 equals to 0, which implies either k equals to 0 or k equals to 6. Now, as we can see, this equation, the quotient of x square is k, and in a quadratic equation, we have discussed earlier that in a quadratic equation, the coefficient of x square cannot be equals to 0. Here, the quadratic equation ax square plus bx plus c equals to 0. In this equation, a should not be equals to 0. So the coefficient of x square cannot be 0. So k cannot be equals to 0, as a equals to k. The value of a is k, that is not equals to 0. Therefore, k will be equals to 6. So this is our solution. Okay, and we'll look at one numerical where we'll need to find the discriminant and check if the solution exists or not. So one example relating to, say, a pole has to be erected at a point on the boundary of a circular park diameter 13 meters in such a way that the differences of its distances from two diametrically opposite fixed gates A and B on the boundary is 7 meters. Is it possible to do so? So whenever you are asked this question that is it possible to do so, you need to understand that the first point that you will be checking is the discriminant. If the discriminant is greater than or equal to 0, then it will be possible, else it will not be possible. If yes, at what distances from the two gates should the pole be erected? Okay, suppose a pole has to be erected on a point on the boundary of a circular park. So we have a circular park. A circle has a diameter of 13 meters. So diameter is 13 meters, and a pole has to be erected from a point. Say pole we are erecting from a point in this way, in such a way that the differences of the distances of the from the two diametrically opposite fixed gates A and B. So one of the gate we are mentioning as A, the other gate as B, on the boundary is 7 meters. So the differences, so let the pole be at point P, and this is the boundary where gates are there A and B. So the difference in the distance of the gates, so according to question, AP minus BP is equals to 7. This is given to us. Okay, and let's say let one of them will take as x because we don't know either of them. Let's say PP equals to x. So this implies AP will be equals to 7 plus x. Okay, so BP is x, we assume this is x plus 7. Okay, so we know that the angle in a circle, semicircle, is 90 degree. So this should be 90. Whenever we have a diameter, and from a diameter, if we join these two lines like this in the circumference of the circle, from the diameter it always makes an angle of 90 degree. Basically this is a theorem which says that the angle in a semicircle is right angle. So angle APB equals to 90 degree angle in a semicircle. So in triangle APB, using Pythagoras' theorem, AB square equals to AP square plus BP square, which implies AB square is 13 square equals to x plus 7 whole square plus x square, which implies 169 is equals to x square plus 14x plus 49 plus x square, which implies, let's say 169 we take to the other side, so 0 equals to 2x square plus 14x plus 49 minus 169, or we can write this as 2x square plus 14x. So 49 minus 169 is minus 120 equals to 0. 2 comes common, x square plus 7x minus 60 equals to 0. So 2 goes to the other side, so 0 by 2 is 0. We have x square plus 7x minus 60 equals to 0. So this is of the form ax square plus bx plus c equals to 0, where a is 1, b is 7, c is minus 60. So it would be possible to place the pole if this equation has real roots Therefore, the discriminant b square minus 4ac, this is equals to 7 square minus 4 into 1 into minus 60. So 49 minus minus plus 6 4s are 24. So 240. So this is equals to 289. So b square minus 4ac is 289. That is greater than 0. So the given quadratic equation has two real roots and it is possible to erect the pole on the boundary of the park. So therefore x will be equals to minus b plus minus root under of b square minus 4ac by 2a. This is equals to minus b is 7 plus minus root under of b square minus 4ac we saw is 289 by 2 into 1. So this is equals to minus 7 plus minus root 289 is 70 by 2. So which implies either x equals to minus 7 minus 17 by 2 or x equals to minus 7 plus 17 by 2. So this implies either x equals to minus 7 minus 17 is minus 24, minus 24 by 2 is minus 12, or x equals to minus 7 plus 17 is 10, 10 by 2, 5. So either x equals to minus 12 or x equals to 5. So this is the distance between the four. So as x denotes the distance between the poles, so x is not less than 0. Therefore, x will be equals to 5. So x we took as the distance from gate B. So thus the pole has to be erected on the boundary of the park at a distance of 5 meters from gate B, and gate A it was x plus 7. So 5 plus 7 and 12 meters from gate A. Okay, so with this we come to end of today's class. Thank you.